Tech giants are currently racing to build massive million GPU clusters to train the next generation of AI models, but that scaling effort has slammed into a hard physical limit. For decades, data centers have relied on electrons moving through copper wiring to transmit data. When you push those electrons at terabit speeds, physical resistance generates catastrophic amounts of heat. This bar chart breaks down total power consumption in a massive AI cluster. You can see that a staggering 30% of all energy is wasted simply forcing data across these copper interconnects. Engineers are currently trying to push 200 gigabits per lane over passive copper cables. At those speeds, the signal degrades so rapidly that the maximum reach shrinks to less than a single meter before the cables risk melting or losing data entirely. To keep scaling, the industry is replacing those electrons with photons, transmitting data via microscopic pulses of laser light. To prevent a massive energy bottleneck, data centers are shifting their high-speed data paths away from copper and toward the efficiency of fiber optics. In legacy network designs, electrical signals must travel across inches of printed circuit board to reach pluggable transceivers at the far edge of a server rack. Maintaining an 800 gigabit per second connection across that distance requires up to 17 watts of power for every single port. The solution is co-packaged optics. Instead of edge transceivers, manufacturers embed optical chiplets directly inside the main processor package. This shrinks the electrical path to under 1 millimeter. Data translates to light instantly, bypassing copper's degradation. This integration drops power consumption by 70%, unlocking multi-terabit bandwidths. By solving the I/O bottleneck, co-packaged optics severs the tie between processing power and astronomical energy usage, making rack-scale AI clusters physically possible. When you take these individual optical packages and link them across a massive data center floor, the network topology changes completely. New material science breakthroughs, specifically electro-optic polymers, allow these lasers to modulate light at higher speeds without producing excess thermal waste. Startups like IR Labs are already proving this out in production, building 1,024 GPU rack-scale reference systems that utilize pure optical pathways. With data moving at the speed of light, thousands of distinct GPUs can pool their high-bandwidth memory with picosecond latency, effectively functioning as a single enormous synthetic brain. Tracking the transition from the thermal constraints of copper to the higher bandwidth density of light reveals where the infrastructure capital is actually flowing. And if you want to leverage modern AI tools to scale your own business operations and digital assets, you need the right system. That's exactly what TechViews10x.com provides. Click the link on screen to access the platform and start building your position in the AI-driven economy today. In the first half of 2026, the Silicon Photonics ecosystem transitioned into volume production. TSMC triggered the shift when their COUPE Silicon Photonics platform hit mass manufacturing in April. On the networking side, Broadcom is shipping its Tomahawk 6 co-packaged Ethernet switches, allowing hyperscalers like Meta to build custom optical hardware optimized strictly for their own models. NVIDIA is countering by integrating Quantum X InfiniBand photonics directly into their proprietary stack, locking customers into a highly unified optical ecosystem. Look at this line chart mapping hardware demand. You can clearly see the steep upward trajectory for the optical transceiver market, exploding to a projected $26 billion valuation by the end of 2026. By finally circumventing the strict thermal and distance limits of copper, Photonics has cleared the path for million GPU clusters. The firms supplying this architecture will lead the next decade of data center growth. To stay ahead of these rapidly shifting hardware cycles, head to TechViews10x.com and make sure to subscribe for more.